Okay everyone, let's take a look at Chapter 3, Electrical Circuits and PLCs. Switch symbols are drawn to provide a visual indication of how each switch operates in a circuit. Any normally open switch that is manually operated has the operator of the switch drawn above the terminal, and any normally closed switch that is manually operated has the operator switch drawn below the terminal. Electrical switches are drawn in normal condition or activated condition on electrical prints. Switches are drawn on prints in the operating condition the switch is most likely to be in at any point of time. Not understanding how manual and mechanical and automatic switch symbols are drawn makes circuit understanding and troubleshooting difficult. Solid state switches start and stop the flow of electricity in a circuit without the use of moving parts. Solid state switch symbols show the actual switch symbol in a diamond shape. Programming symbols for the input devices are drawn as generically normally open or normally closed contacts, and all output components are drawn as parentheses. Special symbols are used in PLC programming when a PLC has advanced control functions. Pictorial drawings are used to provide a visual picture of devices, components, and wiring. Wiring diagrams show the connection of all devices and components to a PLC. Thermocouples are connected to analog PLC input terminals because thermocouples produce a voltage proportional to the measured temperature. Line diagrams use standard electrical symbols to indicate what type of input devices and output components are being used in the circuit. Standard line diagrams and PLC programming diagrams are similar, although different symbols are used to represent the same device or component. All electrical control circuits that use any type of switch to control loads are comprised of switching logic functions. All input devices of an AND logic circuit must be activated in order to energize the output component. Only one input of an OR logic circuit is activated in order to energize the output component. The input of a NOT logic circuit must be deactivated in order to energize the output component. Only one input of a NOR logic circuit must be deactivated in order to de-energize the output component. All input devices of a NAND logic circuit must be deactivated in order to energize the output component. In direct hardwired circuits, the power circuit and control circuit are wired point to point. Adding forward rotation indicator lamps and reverse rotation indicator lamps to a direct hardwired circuit is difficult because the exact connection points for the lamps must be found. To make modifications to direct hardwired circuits typically requires the removal and/or addition of circuit wiring. Hardwiring using terminal strips dramatically simplifies circuit troubleshooting. Modifications are easier with terminal strips because most, if not all, of the wires required to make a change are disconnected and reconnected at the terminal strip. When using a PLC to control a circuit, all input devices are wired to the input module of the PLC and all output components are wired to the output module of the PLC. Alright guys, that was it for that chapter. Next chapter will be chapter 4. I'll see you over there.